Hello everyone, this is Vipul and I welcome you all to my YouTube channel. My dear friends, in this particular session, I'm going to discuss about the first topic which comes under thermodynamics applied to solutions. So to begin with, the very first question which comes to our mind is, what do you mean by solution? Solution is basically a mixture. Now that mixture is generally considered to be homogeneous. That means it's going to consider one particular phase. But the physical state may be different. And it's a mixture. When I talk about mixtures, obviously there will be at least two substances which are going to be present along with each other. Now generally when you talk about a solution, it has a major component as well as a minor component. And hence, we say that solution is a mixture of solute and solvent, where solute is in the minor component and solvent is the major component. Now, when we talk about the miscibility, now that means suppose if I consider the solute and the solvent both in the liquid state, then I use the word miscibility. So when we consider the miscibility of the two liquids, and then we say that there are three possibilities. First one is, we have a completely miscible mixture. I give an example of water and alcohol. We can also have a partial miscible mixture. That's going to be water and phenol. And the third possibility is both the liquids are completely immiscible. And the example for that is water and iodobenzene. Now, my dear friends, the most striking feature over here is when I gave you the examples, you must have noticed that in all the three cases, the solvent is the same, that is water. But still, the miscibility differs. So from this I want to say that the miscibility not only depends on the solvent, but it also depends on the solute as well. Next is when we talk about the nature, what type of nature of the solution is, then we primarily say that they are of two types. One is known as an ideal solution and the other is known as a non-ideal solution. Now, as we progress through the series of this particular chapter, I will be explaining you in detail about what exactly is ideal and non-ideal solution and how they differ from each other. All right? Let's move on to the next point now, and that is vapor pressure. Now, as you understand, vapor is that physical state of a substance which exists in a gaseous state. And whenever we talk about pressure, we generally talk about gases. All right? So, we say over here that the pressure which is exerted, okay, what we say is the pressure which is going to be exerted by the liquid or by the vapor on its own liquid, that is called as vapor pressure. Okay? Once again I repeat, it's the pressure exerted by the vapor on its own liquid. This is very important. That means suppose if I take a beaker containing water and I start heating it, at one particular temperature it starts boiling. Okay, so this is a situation where I have water vapor as well as the water. When I use the word water vapor, so that means it is gas. And when I use the word water, it's a liquid. Now, if I cover that particular beaker with a lid, then what is going to happen is that water vapor is going to exert the pressure on water, both of which having the same chemical composition, that is H2O. All right? So, pressure exerted by the vapor on its own liquid is known as vapor pressure. In other words, it can also be called as the escaping tendency of the liquid. Now you know very well, gas is that state which is going to be lighter and hence it can easily escape. So if I want the liquid to escape, what I need to do is very simple. I need to convert that liquid into vapor. Okay. So the vapor pressure can also be seen upon as escaping tendency of the liquid. So the tendency of a substance to leave its thermodynamic state. Now this can be anything. Alright, it can be either by a physical process or a chemical process. When I say by heating, so it's physical process. Or you can also carry out some chemical reaction by which the liquid can be converted into vapor. And hence, when we relate this vapor pressure and escaping tendency, so obviously when I say that vapor pressure in other words can be called as escaping tendency as well, so it's very obvious that both of them are directly proportional. So if vapor pressure increases, the escaping tendency is also going to increase. Alright? So this is what we need to consider. Next point is, if I consider a liquid having a lower boiling point, then it has got a higher escaping tendency. I give you an example. Boiling point of water, everybody knows it's 100 degrees Celsius. And boiling point of acetone is 56 degrees Celsius. So it's very obvious now that we can achieve 56 degrees Celsius faster as compared to 100 degrees Celsius. Or in other words, at 56 degrees Celsius, acetone gets converted into vapor, but water remains as water itself. And as soon as the acetone gets converted into vapor, it starts escaping out. So who's going to escape first? Acetone, because its boiling point is less. Okay, so the liquid whose boiling point is less has got a higher escaping tendency, and therefore we conclude that the escaping tendency of acetone is going to be high as compared to that of water. So now if you try to relate all these terms, whatever is being discussed, okay, so that means if I talk about a boiling point, so boiling point is inversely proportional to escaping tendency. Lower the boiling point, higher the escaping tendency. Alright? And escaping tendency and vapor pressure are directly proportional. So if I want to relate all these three terms, then what am I going to say is that if the vapor pressure increases, the escaping tendency also increases and the boiling point decreases. Alright, this is what is the relationship between these three important parameters. So I hope, my dear friends, you have understood the introduction part of this particular segment, which is going to be thermodynamics applied to solution. Okay, please stay tuned for the second part of this particular segment. Till then, take care of yourself. Thank you very much. Bye-bye.